Welcome to another edition of Water Wonder Wednesdays brought to you by the Stormwater Quality Division. My name is Kyle and today we will be showing you how we conduct a stream sampling of water quality using a simple test kit from the EarthEcho Water Challenge, formerly known as the Worldwide Monitoring Challenge Program. Now, just a little info for a little bit about the EarthEcho Water Challenge. It is an international program that runs annually from March 22nd through December and equips anyone to protect the water resources we depend on every day. Now, the Water Challenge builds public awareness and involvement in protecting water resources around the world by engaging citizens and students to conduct basic monitoring of their local water bodies. They will test waters from their local watersheds, share their information online as part of an international database, and then use the information and sampling data provided to take action and implement actions to keep their waterways healthy and clean. Now, here at the Stormwater Quality Division, we regularly team up with the Department of Land and Natural Resources and neighboring schools located in Waipahu to help conduct stream sampling data at Kapakahi Stream, located in Pouhala Marsh. Now, we have done stream sampling and data collection with students from elementary, middle, and high school. These students will work in small groups to conduct their findings. A little bit about Pouhala Marsh. It's a 70-acre tidal wetland located on the southwestern coastline of Oahu and Waipahu. The city and state both own sections of the parcels of the marshlands, but it is managed and maintained by the Department of Land and Natural Resources, Division of Forestry and Wildlife. Here is Ati Fabro, a wetland coordinator and land manager, to talk about the history and the progression of the marsh.
Hi everyone, welcome to Pouhala Marsh. Pouhala Marsh is a wetland wildlife sanctuary managed by the Division of Forestry and Wildlife, part of the Department of Land and Natural Resources. Behind me you can see Kapakahi Stream, which borders one side of the marsh, and then on the other side is Waikele Stream. So this area, when the Hawaiians first came, was full of wetlands. They were able to develop food systems like the wet taro, the lo'is, as well as build numerous fish ponds within this area, which was perfect. So this area was known for its abundance of food and food products. So lots and lots of people depended on this area. As history went on, we had people started looking at wetlands with less enthusiasm. They looked at them as wasted land. It's either dredged and filled or people illegally dumped. And that's what Pouhala Marsh became, an illegal dump. So what you see today is a restoration. It was full of trash and debris and that accumulated for 50 years. We managed to restore it with a lot of community work. Folks like City and County Stormwater Quality Program has come in and helped us educate people about water quality and what enters into Pearl Harbor. So we're happy to have you here and hope that you enjoy the lesson. Aloha.
Now, before we begin sampling, we always take the time to observe the surrounding environment and conditions, not only that we can make a general explanation for the water quality, but also to help describe in detail the location of our testing sites. This is so that if anyone wants to gather data in the same place to compare, they know exactly where to go. So we created a simple worksheet that we modified from the EarthEcho Water Challenge to help identify some general observations, stream width and depth, along with more specific indicators such as plant life, animal life, water description, and the presence of erosion and drainage pipes. Once that has been filled out by the groups as best as possible, we move on to our water quality testing using our kits provided by the EarthEcho Water Challenge. The test kits include a sample cup, vials, and tablets to test dissolved oxygen and pH, and a range card. Altogether, they will be testing for turbidity, temperature, pH, dissolved oxygen, and percentage of oxygen saturation. So now here is a short video of us getting our sample water from the stream using our water bucket. And then we're using that sample water we got to fill the bucket up of our sample cup to the fill line located on the outside of the sample cup. So the first thing we'll be testing for today is turbidity. Now, turbidity is a measure of clarity in the water. A high turbidity can indicate there are solid particles in the stream, such as clay, silt, organic and inorganic materials that are suspended in the water. This can block fish gills, block light for aquatic plants, and absorb heat. Turbidity can be caused by soil erosions, urban runoff, algae bloom, and bottom disturbances. An easy way we check it is by looking at the disc on the bottom of the cup and comparing it to the one on the range card. We have our small groups discuss and come to an agreement on a number. So as you can see here, the water is very clear. So we will give this a rating of 0. Now during this time, I'll also share how these tests are imprecise and the variables of that. For example, their answer was an agreement of the entire group, and some people might see things differently. They might see it in a different light source as well. All these things might affect their results. Now this is still a pretty good general indicator of water quality overall. We usually do bring an actual scientific water quality probe to compare our results to that of our test kits. We test for temperature by looking in the sample cup at the temperature gauge and finding the green line. Now aquatic life are sensitive to change in temperature and require a certain temperature range to survive and thrive. Temperature changes can be the result of for many things, like the removal of trees, vegetation, to runoff from hot pavement. The green lines indicate 24 degrees Celsius and 75 degrees Fahrenheit. So testing for pH is finding the acidity of the water. Aquatic organisms have adapted to a specific pH level and may die, stop reproducing, or may move away if the water is too high or too low in acidity. Here we place a pH test tab into our 10 milliliter test tube and shake until fully dissolved. Then we have the group compare the colors to the range card and agree on a number. A normal range for aquatic life is between 6.5 to 8. A pH can be affected by wastewater discharges or leaching sediment. Now our reading indicates that the levels are at a 7, which is neutral and perfect for aquatic life. Testing for dissolved oxygen is testing the amount of oxygen in the water. Now, natural waters with a high dissolved oxygen levels are most likely healthy and stable environments, capable of supporting a diversity of aquatic life. We test dissolved oxygen by placing 2 dissolved oxygen tabs in the fully submerged glass vial and shake until fully dissolved, and then have the group take the readings from the range card similar to the pH test. Dissolved oxygen can be affected by the temperature, turbulence, and turbidity, along with high bacteria and rotting plants as well. Our test shows it being 4 parts per million. Now from our readings, we can now find the oxygen percent saturation of the water. This is an indicator of how much dissolved oxygen in the stream water can hold. Cold water can hold more oxygen than warm water. We look at the table given to us and use our findings of the temperature and dissolved oxygen reading and see where the numbers intersect. So for us it would be 24 degrees and 4 parts per million, what will come out to 48% saturation. Now we then use our findings and data and have the students enter them into the EarthEcho Water Challenge website with our tablets. The great thing about doing this is now we have substantial data from the spot where we can reference this spot where we did all of our water quality testing. So if you go to the EarthEcho Water Challenge website, it gives you an option to browse past results from all over the world. So if you hover over Oahu, you can see all the different spots on the island that'll show you where it has been tested and garnered data. And if you go into Kapakahi Stream at Pouhala Marsh, you can see the data we have been collecting throughout the years. You can see how the pH has changed over the years. And you can see how the temperature has changed over the years. You can see how the oxygen saturation and everything you've tested for has varied. You can also input pictures, stories, and other data that would be relevant to this site. So a quick recap about the EarthEcho Water Challenge. You can obtain test kits for your classroom or projects through us. Now with the test kits, you can sample water quality in your community, and then you can share your data online with the entire world, along with pictures and info on your community and projects. With the data you have now gained, you can identify issues and concerns with the water quality and formulate solutions and projects. You can ask us here at Stormwater Quality Division for advice, or even go to the website that gives you a listing of ideas and past projects as well to imitate. Now, if you have any questions or in fact interested in doing some water quality testing, please feel free to reach out to us at cleanwaterhonolulu.com. Thank you for your time.